All right, good morning. How's everyone?
Doing all right, Nick. How you doing?
I'm doing all right too. All right, so I want to talk about some final points on PA1. I want to show you some sample execution again. Talk a little bit about parsing and testing, and then I want to start talking about pointers. So any questions before we get into those things? All right. Well, let me start by talking about Git. So I did a sample download of people's Git repositories this morning, and with 45 students, 17 had Git repos, which means about 2/3 of the class does not have a Git repo that I have access to. So I've talked about this in 224, but I'm going to say it again for PA1. When you get an assignment and you know that you're going to have to turn it in through Git, my suggestion is day one, make yourself a repository, right? Go to an empty directory, name it whatever you want, hop in that directory, do your git init, write a readme so you have at least one file, do git add, git commit, and then do your git remote add origin to create the repository link to GitLab. Do git push origin master, which creates the repo. Hop onto the GitLab website, set me up as a reporter. 5 minutes at the most, right? Less if you've done this, enough times and you got the muscle memory. It's a few minutes to set this up. And it does so much for you, right? Because now, as you develop your code, anytime that you hit a stopping point, git add, git commit, git push. Make yourself a little shell script, make an alias called G if you like, that runs this script, and the script does git add, git commit, git push. You can hardwire a git message if you like. And so now you're editing your code, you get out of the editor, you run it, it looks good, type a G, hit enter. And you don't have to think about it after that part, right? From that point on, anytime you make changes, push it over to the repo, and your changes are there. Okay, so this does a few things for you. Number one, if your hard drive goes to lunch, right, and you lose all of your files from your laptop, you've got them all on Git. It's really easy, right? You fix your laptop, you get a new hard drive or whatever, one git clone statement, and boom, you've got your whole Git repository back on your home system, right? The Linux server is not backed up. That could go out at some point, right? Same thing. Computers fail, hard drives fail, data gets lost. It's inevitable, right? You can't prevent it. All you can do is prepare for it. Git's a great way to do that. Number two, you're at Aunt Sally's house for the weekend, and you want to work on your project. You can borrow someone's computer and you can pull down a Git repository and get your latest code. This happens, right? Number three, you deleted all your files by mistake, or you made some change and that change doesn't make any sense the next day and you want to go back to an older version. You got the whole history of it in Git. You got a local copy, you got a copy on the repository, right? And number four, if something happens and you fall asleep early tonight and you sleep till 2 in the afternoon tomorrow and you don't get a chance to submit your assignment, your latest assignment is already submitted, right? And maybe you forgot to add your name to it or something, right? But your code is there and I'll pull down the latest thing that you pushed. And there's no cost to this other than, a few minutes when you first get the assignment. So I'm really, really suggesting that, going forward, when you get an assignment, set it up. Your repo, push it over, add me as a reporter. Okay, and it takes that whole component, and there's a lot of anxiety around Git usually for computer science students. Am I doing Git right? When you're working on teams in Git, am I going to corrupt the repository? You know, do I have the latest code? Git is not supposed to be a source of anxiety. It's not some kind of like torture device. It's really supposed to make life easier. But you got to have habits for that to happen. You know, seat belts in a car are a pain because you got to put them on, you got to adjust them, all that. Once it's a habit, right, you don't think about it. You feel weird if you're in your car and your seat belt's not on, right? Well, after a while, you feel weird if you're editing code and you're not pushing it into Git, right? So it's really just a habit. And I strongly recommend getting into that habit. All right, and let me show you what I'm going to do tomorrow at 12. I'm going to say git clone linked list 1. Okay, this is a shell script, and it does, you know, it goes through a list of users and creates accounts and things like that. But here's the main thing that it does. It does a call to git space clone space git at gitlab.com colon, this is your Git ID slash, this is linked list uppercase L's 1.git. All right, so here's my suggestion. After you've pushed everything over, right, and hopefully you've been doing this along the way, but you know, when you think you're completely done on your Unix system, either the server or your laptop or whatever, go to a completely empty directory, right? Make a new directory, change into that, and do a git clone. Git clone git at gitlab.com colon my name slash linked list 1.git. And that should pull down a copy of your repository and create a subdirectory named linked list 1. Okay, now cd into linked list 1. That's exactly what I'm going to see when I pull down your repository. So it should contain your source code in a make file. Say make sure it builds your executable. And then run your executable and try a few commands. Right? If you try to do that and when you pull down your repository it says no such repository, you've got a problem. If you pull down your repository and you say make and it says can't find make file, you know you forgot the make file. Or it says, you know, compile error such and such, right? Or you run your program and it says seg fault, right? You're mimicking my experience, right? This is exactly what I'm going to do starting Saturday afternoon. And so there should be no surprises, right? If you try to do this and you get some kind of error condition, you can be pretty sure I'm going to experience the same thing. Now the only thing that this will not check is, did you add me as a reporter? And remember, when we first start an assignment, I invite you to add me as a reporter that day and send me an email and say, hey, can you download my repo? You do that day 1 and I'll pull down your repo and I'll say either yes it worked or no it didn't work, and then you don't have to worry about that part of it. So it is possible to completely take the mystery and the suspense and the terror out of working with Git, and therefore out of submitting your code, right? And you're spending all this time and energy writing your code. You want to get graded for it, right? And you don't want to lose those 40 points because, you know, the moment I tried to download, it wasn't available, or I wasn't set up as a reporter or something like that. So Git Habits, right? I recommend those strongly. I will talk about makefiles in a minute. Let me run through PA1 sample code, and then let's talk about makefiles after that. So. Alright, so sample PA1 execution. So we looked at this when I first gave the assignment. Let's just look at this again. So I run my main program, and it just prints out a prompt. Okay, if you want to print something more than that the first time when you first start your program, that's okay. If you want to say, linked list program, here's my commands, that's fine. But after that, you should prompt with a greater than followed by a space and let the user type a command. And so I can say, insert a 10, success, right? Single line of output, success, followed by a prompt. Insert a 30, success. Insert a 10, node already in list. Print, delete 30, that fails. Insert 6, insert 100, insert 1, and print. All right, so what are we seeing here that's important for your submission? Each command that you type in that is a correct command produces a single line of output. Success, node already in list, a list of numbers. Right? As long as the person types a legal command, you should print out a single line in response and then another prompt, which is a greater than followed by a space. Okay? You don't want to print out a list of commands every time the user hits enter. You don't want to print out additional information like list currently has 2 things in it, right? That's cool to be able to know, be able to calculate and so on, but for the code you submit for grading, I don't want anything outside of the spec. The commands are processed on a single line. To insert the number 10, I don't want to say I, hit enter, and then type a 10 and hit enter again. Right? I want to process a single line command. All of my commands can be entered on one line, I space 10. If you type in something that's not a recognized command, go ahead and print an error message and show the person what the legal commands are. So if I hit a question mark, go ahead and give me a help message. If I just hit an enter, go ahead and give me a help message. But if I type something legal, right, just tell me success, node already in list, whatever the instructions say you should print out. All right, and I'm going to hold you to this specification. Okay, so why am I doing that? I mean, if you say, done instead of success, or you say success in lowercase, right, is that really going to confuse me? No. If you don't have a space after the greater than sign, it doesn't say in the prompt you have to have a space, so you don't have to have a space. It's kind of traditional to put a space in there, but that's okay. You won't lose points for that. But if you print out success in lowercase, you're going to lose points, right? And why am I going to take off points? Because I don't understand what lowercase success means? No, I can read lowercase as well as uppercase. But suppose you were developing this function and it was going to be used by another piece of code. And that other piece of code needed to know if the insert succeeded or not, so it was going to look at the response and say if string compare response to success, then do such and such, right? And if you print out lowercase success, well, string compare doesn't know that that's the same as uppercase success unless you tell it. And if somebody gave you a spec and said, when you succeed, print out uppercase success, they're not going to say, or lowercase, or, with an uppercase S in the beginning, or maybe just SUC would work fine. Or if you say good, we'll take that as success too, right? So you're following a spec because, the code you develop will generally be used by other pieces of code. Now, it's not so common that you would produce output and that would be ingested and parsed. You would probably respond, with a binary value or something. But I want to get you in the habit of following specs to the letter. And as you move on to a university, this is going to become more and more important, right? And the level of dogma will generally rise as you go higher through your education and then into the workforce. And when you're developing code, for a client, you got to be able to follow specification exactly. The repository must be called linked list uppercase L's, nothing else, right? And that's actually more than just being dogmatic. If it's not called linked list with a 1, it's not going to get downloaded when I download. And when I get to grading yours, it's going to be an automatic 40-point deduction, and a note in Canvas saying, you have 24 hours to correct this. So that's critical. If you call the repository something different and then you try to rename it, that does not always work, right? So again, before you consider yourself done, go into an empty directory and do a git clone, try to pull down linklist1.git. And if you just rename, PA1 to linklist1, that's not going to work, which means when I try to pull that down, it's not going to work. So easiest case, easiest way to deal with that, just make a totally new repository, right? Make sure you have your code on your machine, and if necessary, delete the repository from GitLab on the website, right? Make copies of your code first, and then just do the git remote add origin. The name is in the assignment. It's linklist1 with uppercase L's, but look at it in the assignment when you're actually ready to make the repository. All right, so yeah, I want you to follow this specification as exactly as you can. Let's see, there's a question. Does there need to be a space between the character and the number? I don't believe so. So if I say insert 5, that should work. And again, the general guideline here was if scanf likes it, you're fine. So if you look for an I space %D and you don't have a space, scanf will still accept it. So that's totally fine. I'm not going to try to break your parser other than, I will do I with nothing after it. That should report an error. I'll do a D with nothing after it. That should report an error. I'll do an S. That should report an error. And I'll also try to insert haha, and that should give me an error. Or delete, or search. But that's as far as my syntax checking will go. So having an argument that's either not a valid integer or not present. Those things should give you errors. All right, let's see. You can use anything you want that will work. So if you had used fgetc, then you have to be building up a line on your own and just make sure that it works correctly. Because usually when people try to parse character by character, you end up introducing bugs. But if you actually used fgets, which you say you did, you should be fine. But you got to use fgets and scanf, because if you only use scanf, I'll find a way to break your program. So, I won't be trying to do that, but in my tests, it'll end up breaking. So make sure you're sticking to fgets and scanf. And so this ties into on Canvas. There's this additional C book. If you're having trouble doing the parsing, I suggest looking at this. This is a free download, and the first chapter 1's an introduction, but the first real chapter, chapter 2, basically talks about using fgets and scanf, right? It talks about why we don't want to use scanf and how we use fgets to do input and then scanf to do parsing, so we break those up. And it's got some short code snippets that will help you do that. And this is 3 or 4 pages basically, so you can go back to the 224 videos, you can find them on the index and review those, but it's lots of hours of lecture during which we talked about fgets and scanf. So this is a quicker way to get into that. And this text is something I put together for this class, right? I put this together as kind of a moving from CSE222 and the C we do in 224 up to more intense C programming. So it's got an a chapter on input and parsing, which is what we care about here, including comparing strings, right? So how do you know if the person typed in a certain string? And then some bit with string processing that might be useful. And we're going to start talking about pointers at the end of class today, and there's a chapter on pointers. and it's 10 pages long, right? So if you've never done pointers before, this probably is not a good place to start. But having done pointers in 121, and having done indirect references in 270, if you've done 270 yet, right? This is probably pretty close to the right level to jump into refreshing on pointers. And there's a section on makefiles. I don't know if it's any good. I didn't even know that was in there. Let's see what I do on makefiles. Hey, it's got some stuff, and it should have a basic sample makefile. So yeah, 2 or 3 pages on makefiles. So take a look at that if you're confused on some of the stuff. Download it, keep it around. It's small. It's like 100 pages, but it's very, very dense. So it should have some value there. All right, let me go through here. We still need to talk about makefiles. Is size of struct array over size of struct array 0 a reliable way of determining the size of a struct? You cannot determine the size of an array in C. Can't be done. Now the exception is if in your program you say, you know, variable type array bracket 100, and in that same function where you made that declaration, you do something like the size of arithmetic, you should be able to figure it out. But you know the array is 100 because you just declared it to be an array of 100 a few statements earlier. But if you pass that array to a function, you cannot find the size of the array. It's just not available. And in that function, if you say size of struct array, it's going to come back with 8 because that's the size of the pointer. And I'm assuming struct array is a pointer to your variable type. So size of will be a pointer, and you know it'll be 8 divided by whatever the size of the array element is, and you'll get probably 0 or 1 or 2. So arrays, we can't determine the size just from knowing where the array starts in memory. You have to pass along a separate variable. But we're not going to be doing arrays for most of the rest of the course. So. And for PA1, we know the array is 100 because it's hardwired at 100, and that's why it's hardwired at 100. So you can make that a magic number. All right, let's talk about makefiles. So and again, if you go to the list of videos, there's a quick intro to makefiles, and it's 17 minutes long, so it doesn't take a whole lot of time. And so that's one source, but basically makefiles are a way to describe the compilation and linking that needs to take place to build an executable. And so your basic makefile, which should be called makefile, uppercase M, is pairs of lines. And the first line is a list of dependencies, and the second line is a recipe. So your dependency looks like this. You have some target you want to build, and then a list of files that need to be up to date for that target to be built. If all of these files are up to date, meaning that the target was built after the update time and date of these files, nothing happens. But if the target is older than one of these files' latest change, you'll execute the recipe, and this is typically something like, you know, a GCC command to go ahead and build this target. So the recipes have to begin with a tab instead of 8 spaces. So it's not the indenting that matters, it's the tab. And so typically, you know, we would have our main program, which might depend on a few objects. And if we have those objects and they're up to date, then we make our main program by linking together these objects. So that's the first thing. And then for these requirements to build main, well, those are further targets in our makefile. So we tell the makefile, how do we make main.o? Well, we make it by saying gcc-c main.c. Well, what needs to be up to date in order for main.o to be up to date? Well, maybe this depends on main.c. And maybe we have an include file defined that sets up structures and stuff like this. So maybe there's, some include file.h. So this line of the makefile says, look at when inc.h and main.c were modified last. And if any of those were modified after main.o was last created, we need to rebuild main.o. Here's the command for doing that. And so your makefile is just a whole bunch of these pairs of dependencies and recipes. And with include files, right, those are dependencies because if main.c includes this file and this file changes, we need to recompile main.c because the source code is effectively different. It includes this file that's been modified. But we never put an include.h down here on the GCC line, right? We don't ask the compiler to compile include.h, but it will get compiled because it gets included inside main.c. All right, and then the other thing that you always want in your makefile is a clean command. And your dependencies for this, it depends what you want, but basically just remove the things that your makefile builds. So in this case, I'm going to remove my .o files in the main file. And then if I say make clean, it'll go ahead and do that. You can do a lowercase makefile also. Make will actually look for either uppercase makefile or lowercase makefile. But don't do them both because then you got to know about the order. Alright, so there's sample makefiles in that book. There's sample makefiles in the lectures from last quarter. Clean should get rid of the executable program, that's the main program, and all of the objects, the .os. The goal of a make clean is so that you force it to recompile everything from scratch. And the typical example would be if I downloaded your repository and it had, a fully built project, but I downloaded it to a different architecture. So you built it on an x86 and I'm running it on a Raspberry Pi, which is ARM based. If I try to run your executable, that's ones and zeros that an x86 understands. My Raspberry Pi doesn't understand it. So I need to recompile everything. So I say make clean, and that will force it to, by getting rid of all of these, it'll force it to redo all of these GCC commands. So there's a question about input format. When I test your code, I'm going to say I space 5. So it should accept I space 5. If it also accepts I5 without a space, that's okay. But the assignment is written up and the sample code as demonstrated is a letter followed by a space followed by a number. So, but if you use scanf, search for an I%D, it'll do either of those, right? Just don't start parsing things character by hand and you should be fine. I don't know how you easily force a scanf to look for a space between characters. Like I say, you're not required to have a space between characters, um, but you could search for two characters in a row, um, and the first one will be I, and the second one will be a space. But if you're curious, if you're really trying to do a very particular syntax, I'm not even sure I would use scanf. Right? If, for example, if you wanted an I followed by a space followed by a number, right? I would just check to see if character 0 was an I and character 1 was a space. Just, command bracket 1 equals space. The sort of purpose of these scan functions is to do the more general stuff, right? Like taking in a series of digits and is this an integer? Right? Or is this a floating point number which can have so many different representations? Or, is it an integer that starts with a 0, which means an octal number? Or is it a hexadecimal number? Right? So scanf does those things for us. We don't have to use scanf, though, to parse. And a lot of times it's easiest to parse things by hand by just looking at a particular character. So let's talk about parsing a bit. So PA1, you have the following commands: insert a number, delete a number, search for a number, print, exit, or other stuff. All right. So I see three groups of command types here. The first group is a letter followed by a number. The second group is just a letter, and then the catch-all is, print out a help message because they didn't type in something valid. So I would write three sets of code, right, for responding to this. You can jump right in with scanf, but you don't have to. And scanf doesn't really work terribly well for picking up something like a P or an X. Scanf is really for converting, a string of digits to an integer, for example. So let's suppose, we read in a command from the user using fgets, and we want to understand what that command is. Well, the way that this language is specified, the first character tells you a lot of what you need to know. It tells you what kind of command this is. So we can start our processing by looking at that first character. So if command bracket 0 is an I, we know the person's trying to do an insert. So for the case of an insert, we need to pick up a legal integer. So here we're going to use scanf. So if scanning command with the format I%d, save the result in some integer. If this returns a 1, we know that the command was in the form I followed by an integer. And so, add your number to your linked list. If the command started with an I, but they didn't type I followed by an integer, they typed something wrong, so give them some help. Right? So that's a really easy way to process the input command, right? This tells us that it's an input command. This checks to see if it's a legal input command, and if it is, finds the number, calls the add function. Otherwise, gets some help. Otherwise, see if they typed a delete command. And if they did, same thing. Try to parse it out. If it's a valid number, call delete. Same thing for a search. And remember, sometimes you have to do other stuff, right? If you're trying to insert a number, before you insert, do your search. Make sure the number is not already in the list. And if it is, print a message. If it's not, then go ahead and call add and save the return value from add and print either success or out of memory or whatever the messages are in the assignment. But this is pseudocode, right? We're just looking at the parsing. So you do this for D, you do this for an S. For print an X, right, if command bracket 0 is a P, just call the print method. And if it's an X, you can just say return. Yeah, so someone says they check buffer 0 for each case and parse if necessary. That's exactly what we're talking about. So I think that's a great way to do it. Now all of these if-else's work great in a switch, right? And you can do this for all the cases and then just put an else. You know, call a help function at the end if it didn't match any of these cases. But you know, this is coding style issues. All of this is the input command. So this is identifying an input command, it's checking the syntax, it's processing it if it's correct, it's dealing with it if it's not correct. That's the whole input command, and I don't have to think about input once I move past this curly bracket. So I would probably, if I was doing this in a function, I would return at this point. Just like, get out of here, right? If I'm doing this inside a loop, I would probably say continue at this point to go back up to the top of the loop, do another fgets, right? Or you can string together a bunch of if then else's, right? And this works great with a switch statement, right? Switches are really nice in these kinds of situations, so you can switch on command bracket 0. I don't know if it's default or otherwise. I get confused between C and Java. Right? But this is a whole bunch of if-then else statements, right? It basically looks at this first character of your command. If it's a P, it will do all of this stuff. If it's an I, it'll do all of this stuff. You can set up a catch-all case where it's none of those cases above, and that's where you just print out your help function. And you put a break after each of these to say get out of the switch statement. So now you don't need if-then else's, you don't need indenting and nested parentheses and so on. There's other ways to do this, right? But this is one approach. If it looks reasonable to you, go ahead and run with it. If you're doing something else, that's great. Remember, we cannot compare strings with equal signs, so we can't do something like this. Right? That's not going to work. Because CMD is a memory location. Double quote X is a memory location. They're not going to be the same memory location. They might refer to a location in memory that each contains the same character X. But these things are not equal. So the double equal won't tell you if the command matches that pattern. I was having camera issues earlier and I seem to have solved it, but introduced some really bad lag. So sorry for the annoying video. Alright, so any other questions about parsing? Would the I within scanf be within single quotes? So when you put in a search pattern in scanf, it's got to be in double quotes, right? Because you're giving it a string. But what it's going to search for in this command is a single I followed by any amount of white space followed by an integer. I'm going to close this out and see if that speeds things up. That seemed to help. Alright, so let's see. Question, I have a problem. LL previous next equals LL current next gives a seg fault when LL current next equals my null. That's not going to seg fault at that point. LL previous next equals LL current next. That should not be giving a seg fault at that point. Because LL current next is basically equal to 0, and you can assign a 0 to any variable that exists. But I would check the value of previous in that statement, because a seg fault probably means you're indexing in some bad location. So right before that statement, I would check the value of previous, either in GDB or just add some print statements. Alright, the other thing I want to mention for this and other assignments is definitely develop your code, but test it as you're developing it. Right? Don't write your whole linked list package and then start working on your main program and be working on, parsing input tonight at midnight, and you've never tested your add function, right? Make sure that as you write your code, you're testing it along the way, and you can do that by writing your own testbed main program, right? Write a main program that just calls init, adds a 3, adds a 5, adds a 1, adds a 16, adds a 10, and then calls print. And see if it prints out the right thing. And, when you write your delete function, now add some calls to delete, followed by some calls to print. And make sure it's doing the right thing. And you can build up, this own personal test bed of code that exercises the functions you're developing. And it's really nice to have that, because you make a change, you say make, which rebuilds everything, and then I don't know, make a command called go or something. Just say go, hit enter, and it'll run your test bed on that current version of your code. And you can even have it do some self-testing, like see how many things got printed and so on. And right, you want to try and have a rapid development cycle so that you're spending all of your time in the code that you care about, right, which is primarily the linked list code. Now once that's working and totally nailed down, then you work on the main program. At that point, you never have to go back into the internals of add and search and delete and all of that stuff. You're just calling them, right? And if something's not working correctly, it should be a problem in your main program. So you're trying to narrow your focus to whatever it is that you're currently digging into, instead of, I've written 200 lines of code and I get a seg fault, or, I insert a bunch of numbers and I try to print and I get an infinite loop, right? And where's the problem? Who knows? Let's see, it's an index of LL bracket current. I'm not sure what that means. But if you're getting a seg fault on a statement like the one you posted, before that statement, print out the value of current, print out the value of previous, and one of those is going to be bogus. It's going to be some big negative number probably. And it's probably the case that you were following a trail of nodes and you followed it one too far, or you assigned a pointer in the wrong way and maybe put it in the wrong spot or put the wrong value into a pointer, and then you have to work backwards from there and see where that value came from. GDB will also let you set up watch points, so if you know that there's a bogus value in this variable, you can set a watch on that variable and see where it changes value. If it never changes, it means you didn't initialize it. If you gave it a good value and then it changed to something questionable, right? GDB will stop when it's about to change the value. You can see exactly what's causing that change. And it could also be, you know, something going out of bounds. It could be something in your main program. If you're parsing into a string and you don't have enough space in the character array, that can start stepping on other variables. So there can be lots of reasons for that. Again, here, if you're testing as you develop, it helps you isolate where these problems are coming from. All right, good. Any other questions? All right, let's start talking about pointers. So PA2 is going to be the same assignment as PA1, except we're going to implement the linked list differently. PA1, we implemented the linked list as you know, a bunch of nodes that were stored in an array. PA2 is going to be the same main program, the same linked list, but we're going to implement it by using a bunch of nodes that we just create in memory. So your init function in PA1 goes through an array and clears a valid bit in each entry. That array is basically allocated memory. In your main program, when you say, you know, struct node LL bracket 100 or whatever you called it, you're asking the compiler to allocate space for 100 nodes. So that's a chunk of memory that's been set aside. And every time that you want to add a node to your linked list, you need to put that node somewhere. While your getNode function finds a spot in that chunk of 100 nodes and says, hey, here you go, use spot 17. And it marks a valid bit so that next time you look for a location, 17 doesn't get reused. It's marked as in use. That's what the valid bit means. And then later on, if you delete that node, well, now spot 17 should be available for reuse, so the valid bit gets cleared. Okay? Those things are handled for us by the operating system. And so instead of getNode and releaseNode, we're going to use malloc and free. And malloc is how we go out to the system and we say, hey, I want some memory that I can use. And malloc will give us back the location of a chunk of memory that's available for us, and it will make note that that's in use so nobody else gets that block. And when we're done with it, typically because we called free, that block will be marked as being available. So it gets returned to the free memory pool, basically. So PA2, your main program is going to be almost identical to PA1, and your linked list code for add, search, delete, print will be almost identical to PA1. We're going to have to change the syntax when we interact with nodes, because nodes will no longer be elements in an array. They'll be pointers to locations in memory. But in a very kind of reductionist sense, if we think of the main memory of the computer as an array, then we're doing exactly the same thing we're doing in PA1. We'll revisit this next week, but if you think of the memory of the computer as a huge array starting from 0 and ending with 16 billion minus 1, what is a pointer? It's really just an index in that array. When you have a pointer that's equal to 2000, it really just says, give me element 2000 of this array. Well, that's the 2000th memory location. So pointers are doing the same thing that we're doing when we mimic pointers in PA1. But we're not going to think of this as an array. We're going to think of this as actual memory addresses. And so we're going to have, you know, address of a variable as a way to find where this thing is stored in memory. And we're going to say star some variable and say, I don't want the value of this variable. I want the value of that variable to tell me where in memory is the thing that I care about. And so this is the thing pointed to by this variable. So malloc pulls a memory location from the heap, and it's a different heap from the heaps we'll talk about in this course. But yeah, there's a pool of memory. It's called the memory heap, and it basically finds a chunk in there and marks it as in use and gives you the address at the beginning of that chunk. And that is the heap, which is different from the stack. And someone just posted a link to that. All right, so take a look at that textbook that I mentioned, the free online text, and look through the section on pointers. If you're feeling a little rusty on this, it's a few pages, but it kind of goes through the high-level overview of, you know, what's a pointer, what's an ampersand mean, and so on. There's no class on Monday. Monday's a holiday, so Tuesday we will jump into this full bore, and we'll start playing around with pointers and addresses of variables, and we'll look at this inside GDB and really try to get our brains around this idea of working with memory directly from C code. And then we'll start looking at how we use that to do what we did in PA1, to basically create nodes and tie nodes together using this mechanism of pointers. All right, that's it for our class. I'll see you in 2:15 if you're there. Otherwise, have a great weekend, and I will see you next week.